Hi, I'm Rick from arcadetestprep.com, and this is the 3-week math review explanations and instruction. For all these problems, you do have Desmos, the online graphing calculator. You also have your own graphing calculator or regular calculator you can use. I will leave it to you whether you want to try one of each type first and then listen to the video. And if you know how to do them already, then the video is just extra, but I'm going to go through one of each type here and explain the various methods. So number one is a unit conversion. Mr. Blue drives for 33 minutes and it's 20.9 miles. What was the average speed in miles per hour? So the units are super important. Miles per hour. We can do 20.9 miles over 33 minutes. And if you divided that out, you would get miles per minute, which is not exactly what we want. So there is one more step. I would do this kind of like a chemistry dimensional analysis, if you've ever seen this before. We don't want minutes on the bottom, we want hours. So that's our clue to put minutes up top and hours on the bottom as the units for the next step. Now it's not 1 over 1 because there are 60 minutes in 1 hour, so it has to be 60 over 1. And because 60 minutes is 1 hour, this is basically like multiplying it by a giant 1. And you can times anything by 1 and it's still going to be the thing. So now miles will cancel. We multiply across and we get 38 miles per hour. You could obviously do this in 2 steps, convert the minutes to hours, and then just divide it out. There's various ways to go, but this is one way. So you can press pause and try number 2. And in a minute here, I'm going to do the explanation for 2. And we're back. So 2 is very similar. Set up the exact same way. 60 minutes in 1 hour. We should get 31 miles per hour. As we consider 3xy as a solution of the system, x is greater than 0, what's the value of xy? I will show the algebraic way and then we'll see how much faster Desmos is going to be. So this is a classic substitution problem. You could substitute in the x squared from the first equation to the second equation, and then you might as well distribute that -4 while you're there. Anytime you have both x squared and x terms, you have to get everything to one side so you can factor and solve. So we add that 4x over, we subtract the 20. You always want to make the number in front of the x squared be a 2 if possible, so we can divide everything by 2 here. It's going to make things nicer. And then we factor. We need 2 numbers that multiply to -8 and add to 2. If they're going to add to 2, they need to be 2 away from each other. So 4 and 2, we make the 4 positive, the 2 negative. That checks out. We then set each factor equal to 0. And we get that x is -4 and x is 2. They restrict it to x being greater than 0, so we use the one where x is 2. You can then plug that back into either equation to get the y value. I'd plug it in the first one because that one's simpler. So y is x squared or 2 squared, so y is 4. And then the last step, they want the value of xy. So for some reason they want us to multiply these together. So xy is going to be 2 times 4 or 8. Our alternative, we do have Desmos the entire time on the test. You can graph these 2 equations. And when you graph them, you can click on the points. You can export the point and even label it if you want. So we get our 2 intersection points. We restrict x to being positive, so we want that 0.24 out there. So then you just do 2 times 4 is 8. So Desmos is super powerful for some of these systems. It is worth knowing how to do this algebraically because they may change the problem in a way where Desmos becomes more difficult. But clearly for this one, Desmos is way easier. So anytime you're doing SAT math homework, always have Desmos open. And this is just desmos.com /calculator. So with that, you could do 4, 5, 6. Those are similar. You can pause the video and then come back. So graphing these, number 4, x is greater than 0. 2, 1. So the point is 1, 1. That's the intersection point, so xy is 1. Moving to number 5. Graph that one. They don't restrict this, so we could use either point. So they're not telling us that x is greater than 0. So our 2 points are 4, -3, and 7, 0. In order to get the sum, 4 plus -3 is 1. 7 plus 0 is 7. So 1 or 7 are both possible. And finally, the last one there. The sum of x and y. So the 2 points are 3, -3, and 6, 0. When you take the sum, you get 0 for that first point or 6 for the next one. So those are our possibilities there. So getting fluent there with Desmos is super helpful. Moving on, number 7, a totally different type. So here's the equation of a circle. What's the radius? So the circle equation is one of the few you do have to memorize. It is x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. Notice everything on the left side of the equation is squared, so as we look at number 7, that 10y term is a problem. And so we need to complete the square. So the x squared will come straight down. There's nothing we have to do to that. It's the y term we have to deal with. And the shortcut is you take what's in front of the y term and divide by 2. That's what goes underneath. And we'll see why that is in a minute, and then you can remember that. The reason why that works is because if you FOILed out y plus 5 squared, you would get y squared plus 10y plus 25. So you'd get the stuff you want, but you'd also get a 25. So up here, the first step is not the same as the second, and so you can't replace with something different. So to make it the same, back up here, we have to add back that 25. But of course, we can't just add it to one side, we have to add it to the other side, so that's going to change that right-hand side. Now we're in the proper form. We could say that the center is 0, -5 if they asked, or more importantly here, we could say that the radius is 7. So always 2 steps. You take what's in front of the term, divide by 2 is what goes underneath, and then you square that to see what you add back. So you don't have to do this whole foiling every time. You could just know that you're going to square the number. So with that, we'll do 8 there. Now the one thing I would do first, or 2 things here. One is we're going to have to complete the square on the x and the y. So we're going to end up adding 2 numbers to the other side. I would reorganize this, move the x terms together, leave a little space, then keep the y terms together, leave a space. But we'll see if you can do that one, and then I'll be back to explain. And we're back. So down here should be +4, and that means we have to add a 16 back. Over here is a -1. It's a little funny. 1 squared is still 1, so you're adding a 1 back. And then of course you have to add that 16 and 1 to the other side. So that's why it's D. So go ahead and pause the video. You can do 9, 10, then we'll review those. So you should get D and then C. Now real quick, to graph it in Desmos, I'm going to graph number 10 here. You could graph this one kind of zoom out. Yeah, I guess it's not too bad to use Desmos. So you could make the point, you could pick like the 2 vertical points. Those were kind of obvious because they were on the same line. So from 14 all the way down to -2, that's 16 units for the diameter. So the radius would be half that, or 8. The reason why it's good to know how to do this algebraically is sometimes it might be tough to find points, or they might use variables in here that make Desmos kind of unwieldy. So it is good to know how to do this algebraically. But you could graph it if you really wanted to, is an option. So moving on, week 2, word problems. So number 11, and again, pause this if you want to try it on your own. I'm going to run through this one here. The rectangle has a length of x and a width of x minus 4. Here's the area. What is x? So they do give you this formula on the test. The area of a rectangle is length times width. So we have x times x minus 4 equals 45. You distribute the x squared minus 4x equals 45. Again, if you have both x and x squared terms, you need to get everything to one side, so you can use the zero product property. And then we go about factoring it. This ends in a 5, so I know it's divisible by 5, so I would try that first. 9 and 5 work, so it would be -9 plus 5. Set both factors equal to 0, you get x equals 9 and x equals -5. -5 you can discard because anytime you're dealing with a physical property, it can't be negative. You can't have a negative length. So that's why x is 9. If you ever didn't really want a factor, you do have the option at the end to graph that equation you have. Not a big deal here because the factors were pretty simple to find, but you could also get that 9 and the -5 by graphing the parabola and finding the intercepts. So with that, you can do 12, 13, 14. Pause the video. I'm going to be going through those here. 13 is a little, not tricky, but there's an extra step. You get that x is 6, but that's the width, or at least the way I wrote my equation. So the length is 19. So depending on which variable you use for what, might be a little different there. So I'm going to make the width x, so the length is x plus 5 for number 14. But you can do it the other way. You can make the length x and the width x minus 5. Doesn't really matter. 12 and 7. So x is 7, which then makes the length 7 plus 5, so 12. 15, what is the positive solution? So good to know how to clear fractions. You have two options. You can either put the x over 1 and cross multiply, or times both sides by x plus 4. It's functionally the same thing. It's just a different way to think about it. And then again, we get everything to one side and factor. They restrict it to the positive solution. So when you do x plus 9, x minus 5, you get x equals 5. So with that, you can do 16. X plus 7, x minus 6, so x is 6. Moving on to exponent rules. Pretty narrow way that they do test exponents. One of the things to know is that a lot of it's just getting a common base and then setting the exponents equal. So if I told you that 3 to the t equaled 3 to the 5th, you would know that t is 5. But if it got a little more complicated, there'd be work to do. So like in 17, there's work to do. Generally, you want to get both sides in terms of the smaller base. So the left-hand side will come down as is. It's the right-hand side we want to rewrite. 27 I could write as 3 cubed. And then we have to know our exponent rules, power to a power we multiply. So it becomes 3 to the 2x minus 1 equals 3 to the 9th. You can then drop the bases, bring those exponents down, say that 2x minus 1 equals 9. Add the 1 over, divide by 2, you get that x is 5. So always be looking for that common base, and again, generally you want to make them both sides in terms of the smaller base. So with that, you can pause and do 18, 19. So I'm kind of combining a few steps there, but always show every step on the test, do all the work out, but you should get 4 and then 2. 20 is converting roots into fractional exponents. I always think of exponents as being high. The exponent is usually above the number. So when we convert that first term, the 2 is the exponent, so that's going to stay high as we make it into a fraction, and the 3 is the root that goes on the bottom. The square root is the 1/2 power. So technically there's a 2 out there, even though it's not written. And there is a 1 as the exponent, even though that's not written. The last piece is, what do we do when we multiply? It turns out that we add the exponents. You could either get a common denominator and add them, or you could just throw it all in the calculator. Either way, it turns out you get 25 over 6. So b to the 25 over 6 equals b to the a, so a is 25 over 6. So with that, you can do the next one. And hopefully you get that a is 19 over 6. One more of these, 22. Again, we want to rewrite these. So up top, you got x to the 2/3. On the bottom, you have x to the 5/2. What do we do when we divide? How do we combine the exponents? You can always come back to a simple example. This is obviously a complicated one with all those fractions. But if I asked you about x to the 7 over x to the 2, you would know that that's x to the 5th. Like you could literally cancel out 2 of those x's with 2 of the ones up there. So that's why it turns out that when you divide, you subtract the exponents. So over here, we want to subtract 2/3 minus 5/2 to be able to combine it. And when you do that, you get negative 11 over 6. So x to the negative 11 over 6 equals x to the a over b. So negative 11 over 6 is a over b. And that's our answer. So with that, you can pause and do 23, 24, which are similar. So you should get 1/4 and then negative 1/4. And if any of these are tricky, I would definitely encourage you to print out another copy of this and revisit these in a couple days or a week. The more times your brain has to recall the strategy and practice it, the stronger the connection will be, is the whole game here. And then week 3, finally, functions and percents. Function notation, here's f of x. What is f of 6 minus f of 1? On the test, on the scratch paper, you'll write out that function, and then I like to write it right underneath. That way my brain confirms the 6 is replacing the x. Thus, on the other side, to be consistent, you have to replace the x with a 6. And then you can combine and divide, and you get that f of 6 is 2. We want to do a similar operation for f of 1. So now there's a 1 going in for the x. F of 1 is 5 over 5, which is 1. So then the final step is to combine those. What is f of 6 minus f of 1? It's 2 minus 1, or 1. So the answer there is 1. So with that, you can do those next couple and pause the video. So B or 26, we do a similar operation. F of 7 is 5. F of 2 is 10/3. So our final answer will be a fraction. That difference there is going to be 5/3. For 27, F of 9 is 2. F of 5 is 1. So 2 minus 1, we get 1. And 28, F of 8 is 1. F of 4 is negative 1, so 1 minus minus 1 gets you to 2. '29, so we're talking about growth and decay, talking about percents. Anytime you're unsure about these and you're dealing with percents, you could always start with 100. It makes things nice and easy. So if something decays at 12%, if you started with 100 and it decayed by 12%, well, 12% of 100 is 12. You would subtract that out and get 88. That's the way people think about it, is get the percent and then subtract it, usually. The better way, or the way you want to think about when it comes to constructing an equation, is in one step, what do we have to times the 100 by to get to 88? We would times it by 0.88. So that's what I'd say. So keep that in mind. Mentally, a lot of times we're doing these in 2 steps, but you really want to just do them in 1 step whenever possible. Now, the reason why it's not C, because here's the thing, if you put in t equals 1, A and C would both give you the same number. The problem is when you then put in t equals 2, A will give you the right number, C will give you something totally off the case. So if you wanted to plug in numbers, you do have to plug in numbers for all the answers, because you might have multiple ones that work for a certain point, but only one also works for another point. But with that, you can pause and do the next 3 there. And we're back. Appreciation means going up. So this one is going to be D. And then 31 decay at 11% is going to be A. 32 appreciate 6.5. That one is going to be C. And then 33. So the easiest thing here is to make P 100, because that 20% drop becomes 80. But then the further 10%, it's not 10% of the 100, it's 10% of the 80. So you could either times it by 0.1 and then subtract that, or you can just times it by 0.9. In either case, you get 72. And because we made P 100, that's why it's D. So with that, you can try the next one. And so this one is C. 100 goes to 75, and then 20% of that is 15, so you get to 60. $35. We have a bunch of numbers here. So we'll make the number of tigers in 2012 100. So that makes 2017 184. We walk through the problem with those numbers. If 100 is P% of 184, what is P? So we do 100 divided by 184 times 100%. And you get 54%. So with that, you can do 36. And you should get 45. And one more tricky one here. We want an equation that has no real solutions. What could be the value of t? So Desmos is probably going to be faster here. But algebraically, if we think about what's going on, we're not going to be able to factor it because we want it to not have any real solutions, but we would move the t over. We'd think about the quadratic equation, but we don't care about the entire quadratic. We only care about part of it, which is the part that would give us no real solutions. When does no real solutions happen? Well, that's when you have imaginary, and that's when the part in the root, the discriminant, is less than 0. So we can create an equation there. B squared minus 4ac, we want to make it negative. B is negative 5. A is 3. C is negative t. Very important. So we get 25 plus 12t is less than 0. 12t is less than negative 25. T is less than negative 2 and change. You don't even have to get the actual value because going to the answers, the only one that's less than negative 2 point something is negative 3. So a lot of times you can estimate. Now going to Desmos, we can graph y equals 3x squared minus 5x minus t. We add the slider. We zoom in. So right now when t is 1, there's 2 real solutions. If we check t is 2 or 3, there's still going to be 2 intersection points. So there's still 2 solutions. And you don't have to slide. You could also type in the number. So when I type in negative 2, I still get 2 solutions. When I type in negative 3, the parabola moves above the axis and you have no solution. So Desmos is probably superior there, is the deal. So again, print out these sheets again, retry any of the ones that are tricky. Email me if you have any questions. If we are doing tutoring, I'll see you soon. Otherwise, email me if you have any questions, and good luck.